Dear students, myself Dr. T. Sendil Murugan, Associate Professor and Head Department of Information Technology, Kakatiya Institute of Technology and Science, Varangal. In this video lecture, we are going to discuss about OSI model in computer network. This topic will be discussed under classroom discussion topic. That means first hour we are going to discuss this model in classroom. So before starting my class, we will discuss about lecture outcome. After listening to this video lecture, what capability you have, that is lecture outcome. You can illustrate the information or message are processed in different levels and how is transferred from one device to another. After understanding of OSI model, you can have the idea about how the information or messages transferred from one device to another device. Especially in this particular lecture, you should know layered approach. What is layer? And what are the roles and responsibilities of physical and data link layer? So what is OSI model? OSI means Open System Interconnection Model. Okay. Here. So this model is developed by the ISO. So already we know that ISO means International Standard Organization. So this organization is designed open system interconnection for standard that covers all aspects of network communication. So whatever standards required for computer communication, everything is decided and made the standards by the ISO. So that model name called like open system interconnection. It was first introduced in late 1970s. In 1970s itself is introduced. Okay. So now what they are make the standards that we are going to discuss in the further slides. So before starting this OSI model, just we know how the postal system is working. Okay. So here the sender is there. If you are writing one letter, okay. So the what we are going to do after writing the letter, you put it in the envelope and put it in the mailbox, in postal box. Okay. So that is in the higher level layer. After that, who is picking up, where it is delivered, how it is shifted, we don't know about it. Only we are writing the letter and kept it in the envelope and put it in the mailbox. That is higher layers. Okay, that's why we are saying that is a higher layers. Middle layers. What is the middle layers? The letter is carried from the mailbox to a post office. Some postman will come and take the letters and submit it to the post office. What they are doing it in the post office, the letter is delivered to a carrier by the post office. Okay. So what it will be happen? That letter will be shifted to destination. Okay. In lower levels, it may be shifted by flight, or it may be shifted by train, or it may be shifted by person, or it may be shifted by separate vehicle of postal office. Maybe whatever it may be, we don't know about it. We don't want also. Okay. The information is received received by receiver or not. That only we are going to decide it. So after receiving the destination, it will be reached to the mailbox to the receiver. Then receiver will take the letter and read it, what content it is there. Okay. So this is the postal system of Indian Postal. So same like that, how our information is exchanged in computer network, that we are going to discuss in the further slides. So now this slide is representing 7 layers in the OSI model. Okay. So open system interconnection is a model. It is the standard for computer network that is designed by ISO, International Standard Organization. So according to the OSI model, the network has 7 layers. Okay. So what are the layers? Left side there is a number is there, 1, 2, 3, 4. So we can read the numbers from bottom. Why? Because we are using in the OSI model is bottom up approach. Okay. Bottom up approach. Bottom means we will start from the bottom: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. This diagram also represents some colors. So why they are given these colors? So there is these two layers are bottom layers. Okay, these two layers are bottom layers, and these two layers are middle layers. Okay, and remaining three layers are top layers. In OSI model, three level of layers are there. So that we will discuss one by one layers. Okay. So now we know 7 layers are there. In bottom 2 layers are physical layer and data link layer. In network and transport layer considered as the middle layer. And top 3 session, presentation, application layers are top layers. Okay. Now you can see this diagram, how the layers are communicated. Okay. So this is the device A, the device B. In between these two devices, how the message or informations are transferred. So the 7 layers, how it is working. Okay. So here you can see that interface between these two layers are 7-6 interfaces, 6-5 interfaces, 5-4 interfaces, like that. Each layer have the interfaces. Okay. So how information will be shared from device A? In device A, application will send some information as a message directly. If in case you consider the WhatsApp. Okay. So in WhatsApp you are opening it. That is the application. After opening it, how the data, if you are typing one message, hi, how are you? Okay, then how it will be transferred to this device B, that is represented this diagram. So in between two intermediate nodes are there. Intermediate nodes may be a router or switch or some other nodes, whatever it may be. Okay, so here two intermediate nodes are there. It will cross this message with this intermediator, then only it will reach the destination. Okay, so this is the layer communications. Okay, so here in between how the message is reached to the intermediate nodes. In top layers and middle layers, it is not reaching to the in between intermediate nodes, but in the bottom 3 layers the message will goes to the intermediate nodes. So how it will be working, that we will discuss one by one in the further slides. So this is the exchange using the OSI model, how the data is transferred. Okay, so here we know that this is the layer 1 physical layer. So layer 2, like that, we are given the numbering from 1 to 7. Okay, what is D? D means data unit. Okay, so in OSI model, what is the data unit? So each layer have different units are there, how to represent the data. So that will be represented in each layer, that is D2, D3, D4, D5, D6, D7. So what is H represented as header. Okay, so each layer will update some information to next layer as a header. Okay, so some of the layers have trailers. Okay, so you just see here in layer 2, data link layer only have the trailer. And after reaching the physical layer, the information will be exchanged or transferred through the transmission medium and reach to the destination. Okay, so H means header, D means data unit, and T means trailer. So these trailer may be added for error control or flow control. Okay, so the first layer is physical layer. Okay, so in this physical layer, how the data is transmitted? Actually, some data may be received from data link layer. So that will be converted into the bits. What is bit? Bit means 0 or 1. So in digital format, we can represent any values as zeros and ones. So the 0 is single bit, 1 is single bit. So we can say combinations of zeros and ones is considered as bits. So the frame will be converted into bits, then the bits will be converted into the signal. The signal will be transmitted through the transmission medium that will be reached to the destination. This is the role of physical layer. What is that? It is getting the information from the data link layer as frames and converted into the bits. The bits will be converted into the signals. It may be the electromagnetic signals. Okay, electrical signals or magnetic signals. So electromagnetic signals, that signal will be transmitted to reach through the medium to reach the destination. Okay, so after that, the signal will be converted into the binary values like bits. Then bit will be sent to the data link layer. Okay, so now some physical layer is also concerned with the following. What is the first one? Physical characteristics of interface and medium. Okay, so what is that? So physical characteristics means it's the physical characteristics of interfaces. What interfaces we are used from data link layer to physical layer to data link layer. Okay, it defines the characteristics of the interfaces between the devices and the transmission medium. Okay, so this transmission medium, how much fast, what is the capacity, how much fast the data is transmitted. So according to the physical characteristics of medium and characteristics of devices, it will be varies. Representation of bits. Now I told zeros and ones. We are represented bits as a zeros and ones. It may be encoded as a electrical signals or optical signals. So what is data rate? Data rate means how many data transmitted per seconds. Okay, how many bits are transmitted. So that is data rate. Next one, synchronization of bits. So what is synchronization? Here sender is sending 110 1010 like that is transmitted. The same format of data is reached to the destination or not. So for that, what we have to use, the same clock will be used to both the devices. Okay. So after reaching the signals, so it will check the data is correctly reached or not. Okay. That is synchronization of the bits. Next one is the line configuration. What is line configuration? Already we know that single point connections, that means point to point connection or multi-point connection that we have discussed in the previous self-learning topics. So which line we are used, how we are configured the line, according to that also the physical layer will be work. Physical topology, already we have discussed 4 topologies are there: mesh topology, star topology, bus topology, ring topology. Already we have discussed in the self-learning topics under topologies. Last one, transmission mode. So this is also we are discussed in the self-learning topic. So what are the transmission modes are there? Simplex transmission mode, half duplex mode, and full duplex mode. So these all points are related to physical layers. Okay, we have to remember how the physical layers are working. So finally, the physical layer is responsible for movements of individual bits from one hop. Hop means node. Okay, hop, node, device, session, everything is same. Okay, so one hop to next hop. So that is the physical layer roles and responsibilities. Now we are going to discuss about data link layer. What is data link layer? The upper layer of data link layer is network layer. Already we know about it. Okay. So what is upper layer? Network layer. The network layer is to transmit the data streams. Okay. So what is the data unit used in the network layer? Data streams. The streams of data will be sent to the data link layer. Data link layer, it will convert into the frames. Okay, that is readable format. From the data streams, it will convert into the frames. Frames means readable format. That is called like framing. Okay, that is the primary duty of data link layer. After convert into the frames, in frames, what are the things are there? Some headers are there, some trailers are there. What purpose it is used? It may be used for these operations. So bottom we are mentioned flow control and error control. Okay, flow control means how much data we are sent, it is reached or not, it is transmitted properly or not, that control will be there. Okay, error control means whatever data we are sent, the same data is reached to in destination or not, that it will be controlled by data link layer. Access control, so who will be transmitted or which medium it is used, so that control also will be controlled by data link layer. So the data link layer is responsible for moving frames from one hop to next hop. Okay. So see this diagram. This diagram represents hop to hop delivery. What is hop to hop delivery? So normally we are transmitted information from source to destination. So which is the source? So in this diagram, this is the source and this is the destination. These two are destination. Okay. So how the source is transmitted in between, some routers may be used. Okay. So in between this B is the router, here C is the router, here E is the router. Okay. So from this path A to D, A, B, C, D is the path. Okay. So how it is going? First come the information to this router, then it will comes to C, then it will reach to the D. In case the A wants to send the information to F means first it will send to the B, then B to E, then E to F. The information is going like this. So the responsible of data link layer is one hop to hop. So A to B, that is the responsibilities of this link. This data link layer is only controlled for A to B. Okay. So second data link layer, this data link layer for only A to B. So second this link is responsible for B to E. That is data link layer. Then E to F, like that. If there is no responsibility for A to F, data link layer is not responsible for A to F, only responsible for hop to hop. So you don't forget, hop to hop delivery means it is done in the data link layer. Clear? So now we are discussed about what is the layered approach, how many layers are in OSI model, and what are the what is the physical layer, what are the characteristics of physical layer, what are the things related to physical layer, and what is data link layer, and what is the role of data link layer we are discussed. Okay. So now end of this video lecture, you should know layered approach and roles and responsibilities of physical and data link layer. So now you have clear idea about what is physical layer, what is data link layer. In physical layer, what type of data we are forwarded? Bits. In data link layer, what type of data we are forwarded? Frames. Okay, don't forget it. Data unit of physical layer is bits. Data unit of data link layer is frames. So don't forget it. Okay. So now I am stopping my video presentation and I will continue next layer in OSI model in next video. Okay. Thank you very much for listening.